Good morning, good afternoon, and good evening. Today we're going to cover the first subtopic of topic 2, work, energy, and power, called work and power. Work. The more work that a force does, the more energy it transfers. The amount of work done is simply the amount of energy transferred. Work done equals energy transferred. For example, to lift a dumbbell, you need a store of energy like chemical energy in your muscles. You give the object gravitational potential energy when you lift it. The force is your means of transferring energy from you to the object. The name given to this type of energy transferred by a force is doing work. The amount of energy transferred by a force depends on two things: size of the force, greater magnitude the more work done, and distance moved in the force's direction. Further it moves, the more work done. So a big force moving through a big distance does more work than a small force moving through a small distance. Recall and use W equals FD, or change in energy. So work in joules or Newton meter equals force in newtons times distance meters. You just have to remember 1 joule equals 1 Newton meter, or equal. 1 joule is the energy transferred work done by a force of 1 Newton when it moves to a distance of 1 meter in the direction of the force. Power. Power is the rate at which you do work. The more work you do and the shorter time in which you do it, the greater your power. It can also be called the rate at which energy is transferred, or the rate at which work is done. Two ways you can increase your power when lifting an object. Lift a heavier object in the same time as lifting a lighter object, and lift the object more quickly. Please remember that not only living creatures do work, machines also do work, and we describe their power in the same way. Recall and use the equation power equals change in energy divided by time in simple systems, including electrical circuits. Power equals work done divided by time taken, or P equals W over time. Power equals energy transferred divided by time taken. Watt, which is the unit of power, equals energy or work done, joules, divided by time, seconds. Simple systems, including electrical circuits. We can apply the idea of power to any transfer of energy. Example, light bulbs transfer energy supplied to them by electricity. They produce light and heat. Most light bulbs have a power rating like 60 watts or 100 watts to tell users the rate at which energy is transferred.